This is a nice result. Two cosets are the same. These are two names for the same coset if and only if A is an element of HB. And similarly, you can see exactly the same. B would also be an element of HA then too, but just by symmetry. Because you could just swap the roles of A and B. Example, let's look at our favorite example here. G is S3, H is this. And when are two cosets the same? These two cosets are the same. And so this happens when the identity is in, well, let's look at this. A could be equal to B, and A could be equal to E, and B could equal to 1, 2. Then HE equals H1, 2, right there. And that happens if and only if E is in HB. And there E is in HB. And similarly, we could swap, and we could have A is equal to B, or sorry, A is equal to 1, 2, and B is equal to E, in which case you'd still get A's in HB, because A is 1, 2, and that's in HB, which is HE. So that's what we're trying to get at. Same thing here, right? We get that if A is equal to 1, 3, and then you get those two are equal, and A is equal to is in the element of HB. And if you swap, you get 1, 2, 3 as an element of there. And same thing. So suppose first that HA equals HB. I need to prove that A is an element of HB. Well, by previous theorem, I know that A is in HA. That's pretty clear because HA is equal to the elements of H times A. But look, this is going to give me EA times a whole bunch of other stuff I don't care about, which is going to give me A times a whole bunch of stuff I don't care about. A is going to be in AH. That's what that just shows. Okay, but HA is equal to HB, so I'm done. Isn't that nice? So now let's assume that, and let's show that these two cosets are the same. By B, there exists a little H star such that A is equal to H star B. That's what it means for A to be an element of there, is that A is equal to some element of H times B. I'm going to show containment. So I'm going to show that HA is contained in HB. And by a typical element of HA is little HA for some little. And now I can write HA. I know that A is equal to H star B, like that. And now I can activity, and look, this is an H, so this whole thing is going to be an HB, like that. So I get contained. So HA is contained in HB. Now let's prove the other way. So B is equal to H star inverse A, the same game. A typical element of an HB is HB. HB, I'm going to replace B with this thing. B is equal to H A. This is an H, which means that this is an HA. That means that we have containment, so we get set equality. Thank you.